What does it really mean for an AI to think? Today, we're diving deep into why API design defines modern architecture. APIs constitute the majority of all internet traffic, serving as the connective fabric for cloud native apps, mobile, IoT, and AI. API design is the practice of defining the contract, security posture, versioning policy, and developer experience before implementation. A deliberate design first approach reduces integration costs, prevents breaking changes, and accelerates partner onboarding. In a world of composable business, API design is a strategic capability, not a documentation afterthought. But here's where it gets interesting: the integration tax. Despite massive API adoption, the average enterprise spends 30% of development time on integration plumbing rather than innovation. APIs are often produced ad hoc with inconsistent naming, implicit pagination, missing error standards, and no versioning strategy. This results in fragile consumer applications, cascading failures, and endless support tickets. The root cause: API design is squeezed into the development cycle as a reactive task, not a proactive discipline. The cumulative cost: developer frustration, slower feature delivery, and churn is the integration tax. So, what's the real problem? Let's talk about internal out thinking. Most APIs are generated directly from backend data models, exposing internal implementation details that leak into the contract. This tight coupling means any refactoring breaks consumers. Versioning becomes a negotiation, not a managed evolution. API design without a product lens leads to semantic ambiguity, poor error handling, and overfetching, underfetching of data. The underlying cause: APIs built as an afterthought, not designed as external products for unknown consumers. Internal out design creates fragile dependencies, stifling independent deployability. This raises a critical question: API as a product breakthrough. A fundamental shift: treat every API as a standalone product whose users are developers and automated systems. Design first mandates the API specification, open API. Async API as the collaborative source of truth before writing a single line of code. Contracts are reviewed, mocked, and validated against consumer needs early, enabling parallel backend and front-end work. The breakthrough: product thinking applied to APIs unlocks predictability, composability, and ecosystem scale. This approach decouples API surface from implementation for independent evolution. Now let's zoom in on layered API architecture. A robust API delivery system layers: developer experience portal, API gateway, service mesh, and capability services. The gateway handles authentication, rate limiting, routing, and analytics, while the mesh secures east-west traffic. A central schema registry ensures contract compliance. Mock servers enable consumer-driven contract testing. This layered platform transforms API design from artifact to operational system. Each layer provides specific guarantees: security at the gateway, resilience in the mesh, discoverability in the portal. Here's something most people overlook: design first pipeline components. Essential components: open API specification, JSON schema registry, mock server Prism, automated linters, spectral and contract testing suite, packed. Spec drives, docs, SDK generation, and server stubs. Schema evolution is governed by semantic versioning rules. Mocks simulate API behavior instantly, enabling UI development without backend. These building blocks enforce design consistency and shift governance left. Together, they create a feedback loop where design violations are caught in CI, not production. Think about this for a second: the API lifecycle workflow. Design phase: collaborative open API spec authoring with linting for style and security rules. Review with stakeholders. Develop. Generate server stubs and client SDKs from the approved spec. Implement business logic. Verify. Run contract tests in CI to detect breaking changes. Performance test with simulated loads. Deploy publish spec to Gateway. Auto-generate interactive docs. Deploy services. Monitor, track usage, latencies, error rates, detect anomalies. Govern. Manage version deprecation, schema migrations, consumer notifications. And this is where things get complex. Developer experience as KPI. Time to first successful call, TTFSC, becomes a primary metric. Well-designed APIs reduce it from hours to minutes. Interactive API docs with try-it consoles, clear error messages, and consistent pagination drastically cut integration friction. Developer satisfaction scores, NPS, correlate with adoption, stickiness, and ecosystem growth. Investment in DX directly lowers support tickets and accelerates partner integrations. API products with superior DX see 2 to 3x higher adoption rates. But here's where it gets interesting: business agility and revenue impact. API design consistency unlocks self-service integration, enabling partner onboarding without dedicated engineering. A well-governed catalog reduces discovery effort and fosters reuse, slashing duplicative development. Monetized API products built on reliable design foundations turn APIs from cost centers into profit centers. The ripple effect, faster time to market, seamless M&A integration, and platform extensibility. Design rigor translates directly to business velocity and revenue protection. So what's the real problem? Let's talk about the AI native API. AI agents will become primary API consumers, requiring APIs that expose intent, not just data. API designs must incorporate machine-readable semantics, open API extensions for AI tool definitions, and natural language descriptions. Adaptive APIs with schema suggestions based on usage and auto-generated SLAs will emerge. The future API is a conversation between AI consumers and autonomous services. Designing for both human and AI consumers demands structured contracts with rich metadata. This raises a critical question: polyglot paradigms and edge connectivity. The API landscape diversifies: REST, GraphQL, gRPC, WebSockets, and async API for events all coexist. Edge computing demands lightweight, performant endpoints. IoT requires constrained protocols. An API design system must unify these paradigms under consistent governance, security, and discoverability. The future enterprise runs a mesh of interconnected API styles, seamlessly managed. Unified schema registries and multi-protocol gateways bridge the diversity. Now let's zoom in on the API-first enterprise mandate. API design must be a core organizational competency with dedicated platform teams and design standards. Shift from project-centric to federated product model, central design guardrails, domain-owned implementation. Automation enforces design rules in CI/CD. Developer portals surface approved, versioned APIs. The API is the architecture. Design it deliberately, or it will be designed by accident. The enterprises that master API design will define the digital economy.